Chapter 6, Output. Computers can produce several different kinds of output. Some of the kinds of output that computers produce are text, characters that used to write and words, sentences, paragraphs, text. Graphics, digital representation of visual information, non-text visual information, drawings, charts, photographs, animations. Tactile output like raised line drawings that can be useful for individuals who are blind. Audio, music, speech, sounds in general. Video, images displayed sequentially fast enough that it gives the appearance of movement. The great majority of output produced by computers can be divided into two classes: output that users can see, output that users can hear. That's the great majority, not all, entire. The kinds of computer output that people can see can be divided into two different classes: hard copy and soft copy. Hard copy is output that results in something reasonably permanent on a physical medium. Soft copy is temporary visual effects that can disappear as soon as the computer moves on to something else. The most common computer output device is a computer monitor, which produces soft copy. Monitor, or video display terminal, or VDT, video display unit, VDU, refers to the display screen for video images or the case with the screen in it. Monitors create visual display for viewers to see the results of the processed data. They come in a variety of screen sizes and visual resolutions. Most monitors are rectangular, and their size is described using a number of inches measured diagonally from one corner to the other. Resolution describes how sharp and clear the images can be displayed. Resolution can be described in pixel density, or dots per inch, DPI, but more often they are described in terms of the total screen area, number of pixels in each dimension, number of horizontal pixels and number of vertical pixels. A resolution of 1024 by 768 would designate a screen display with a width of 1024 pixels and a height of 768 pixels. There are two common types of computer monitors: cathode ray tube and flat panel. More recently, organic light diode, OLED, started to become quite popular as well. CRT monitors, the earlier computer monitors, were just constructed just like earlier televisions. Cathode ray tube with a fluorescent screen, displaying images formed by phosphorescent dots on the screen. Flat panel monitors, almost all current monitors are created using flat panel display technology. CRTs are pretty much gone. Flat panel technology covers a growing number of electronic display technologies. They create monitors much lighter and thinner than the older CRT displays. Flat panel monitors are usually less than 10 centimeters thick. They generally use either liquid crystal technology or gas plasma technology. Most modern flat panel displays use LCD technologies, liquid crystal display technologies. Light passes through thin liquid crystals to create display of pixels. LCD screens are usually backlit, making them easier to read in bright lit environments. They are thin, light, provide good linearity and resolution. A thin layer of liquid crystal, liquid that has crystalline properties, is sandwiched between two electrically conducting plates. The front plate has transparent electrodes deposited in it, and the back plate is illuminated. By applying electrical signals across the plates, different regions of the liquid crystal can be activated to control polarization properties. These segments can either transmit or block light. An image is produced by passing light through the selected liquid crystal segments to the viewer. LCDs are used in various kinds of electronic devices, watches, cell phones, calculators, and notebook computers. Liquid crystal displays are lightweight, compact, portable, and cheap. They're also more reliable and easier on the eyes than are CRTs. Very large displays can be implemented using plasma display technology. Gas plasma has wider viewing angles than LCDs, have higher refresh rates, and faster response times. This contributes to superior performance when displaying content with significant amounts of rapid movement. Lower prices, they also have lower prices per square inch than LCDs, which makes them useful for large displays. Plasma displays, however, have lost nearly all market share, mostly due to competition from lower cost LCDs and more expensive but higher contrast OLED flat panel displays. Manufacturing of gas plasma displays in the United States retail market ended in 2014. An organic light emitting diode, OLED, is a light emitting diode, LED, formed from a film of organic compound situated between two electrodes. OLED displays can be manufactured on flexible plastic, leading to the possible production of flexible organic light emitting diodes for new applications such as roll-up displays embedded in fabrics or clothing. OLEDs are used to create digital displays in devices such as television screens, computer monitors, and portable systems such as mobile phones, handheld game consoles, and PDAs. Because the substrate used can be flexible, they're also shatter resistant, unlike glass displays used in LCD devices. Flexible OLEDs are also used in wearable devices because they're lightweight, require very little power, and of course they're flexible and they are capable of displaying a wide range of colors. Wearable technology, fashion with technology, wearable devices, tech togs, fashion electronics, all are describe clothing and accessories that incorporate computer and advanced electronic technologies. These designs often incorporate practical function and features, but they can also have a purely aesthetic agenda as well. Wearables make technology pervasive, interweaving it into our daily lives. One early piece of widely adopted wearable technology was the calculator watch that came out in the 1980s. OLEDs can be printed onto any suitable substrate with an inkjet printer, or even screen printing makes them theoretically, at least in theory, they're cheaper to produce than LCD or plasma displays, although the materials themselves are more expensive than the ones for LCDs. OLEDs also have a much faster response time than LCDs. The biggest technical problem for OLEDs is that they have a much more limited lifetime than do LCDs or gas plasmas. And they're also subject to water damage. A projector or image projector is an optical device that projects an image or moving image onto a surface. Very often that surface is a projection screen. Most projectors create their image by shining a light through a small transparent lens, but some of the newer types of projectors create the image directly with lasers. The most common type of projector is the video projector. Earlier projectors were mostly replaced by the digital video projectors in the 1990s and early 2000s. But you can still find some of the old analog projectors in some places. The newest types of projectors are handheld projectors that use lasers or LEDs to produce their images. Many of these produce images that can be hard to see if there's very much ambient light. Virtual reality headset is a head-mounted device that provides virtual reality for the user wearing it. VR headsets are widely used with video games, but they're also used in other applications like simulators and trainers. They include a stereoscopic head-mounted display, separate images for each eye, stereo sound, and head motion tracking sensors. These sensors might include gyroscopes, accelerometers, and light systems. Some VR headsets also have eye tracking sensors and gaming controllers. Printers produce hard copy versions of processed data. They print out documents, photographs, similar kinds of output. There are three common types of computer printers: inkjet, laser, and dot matrix. Inkjet printers spray tiny dots of ink on a surface to create their images. Laser printers use toner drums, roll through magnetized pigment, and then transfer the pigment to a surface. Dot matrix use print heads to embed images from an ink ribbon onto a surface. Inkjet printers have a number of advantages over the other consumer-oriented printers. They're quieter than the impact printers. They can print fine, smooth details. They have high resolution. Inkjet printers tend to be cheaper than color laser printers, and they're the type of printer most commonly found in homes and small offices because they have good characteristics, they're quiet, high resolution, and low priced. They're lower priced than lasers, especially lower the color lasers, and they're quieter than the impact printers. Documents produced by the inkjet printers can be problematic, depending, of course, on the quality of the ink and the paper that was used. Low quality paper can turn yellow and degrade over time because of residual acid. In the worst cases, old documents can literally crumble into small particles. Of course, this is the property of the paper, not the printer. Any kind of printer using that kind of paper would end up with the same results. Documents printed using high-quality ink on high-quality paper last just as well as typewritten or handwritten documents. The ink in many low-cost consumer inkjets is water-soluble, so you have to be careful with the documents, storing the documents that they produce, avoiding moisture. The moisture could cause blurring or running of the print. In extreme cases, even sweaty fingertips can cause low-quality inks to smear. Water-based highlighter markers can blur inkjet printed documents, and the ink can discolor the highlighter, so it'll carry on to other highlighting. Many inkjet printers use water-resistant pigment-based inks. Resin or silicone-protected photo paper is widely available at reasonably low cost, resulting in complete water and mechanical rub resistance for dye and pigment inks. The photo paper itself must be designed for pigment or dye inks, since the pigment particles are too large to be able to penetrate through the protection layer of dye-only photo paper. Laser printers is an electrostatic digital printing process similar to that used in photocopy. A difference between laser printing and most other printing technologies is that for laser printing, each page has to be set up completely before it starts. Each page is rendered in a single process without pausing to stop in the middle. Other technologies can pause after a character or after a few lines. Laser printing does a page at a time, and the laser printer has to have enough memory to hold the entire page. Dot matrix printing is a kind of printing that uses a print head that prints by pushing an ink-soaked ribbon against the paper. Letters and symbols are drawn out of a dot matrix, drawn by making a lot of little dots of ink on the page, which allows different fonts and arbitrary graphics to be produced because it draws everything a dot at a time. Each dot is produced by a small metal rod or wire pin that pushes forward and pushes against the ribbon, pushes the ribbon against the paper. In the 70s and 80s, dot matrix printers were by far the most common form of printer used with personal or home computers. Problem with dot matrix printing is that they are noisy. They're still preferred where you need fanfold paper or where you need to print multiple copies. Non-impact printers can't do copies. You have to print multiple copies by printing several times. A virtual printer is a kind of computer software that functions kind of like a printer, but stores the output in a file instead of creating the physical image. The output files can be stored, or can be used as input to other programs. They can be used to create PDFs or to transmit the output to other systems or users. A 3D printer is a device for making three-dimensional objects. 3D printers make objects through processes making layers of material, plastics, metals, cement, wood, other materials, laying down one layer on top of another, controlled by the computer. It functions kind of like an inkjet printer, but of course it doesn't use ink. It uses solid stuff that puts layers on top of layers, deposits layers of the material like an inkjet printer deposits ink on the paper. Solid ink printers, phase change printers, are a kind of thermal transfer printer. They use solid sticks of ink, something like candle wax, that is melted and fed into a print head. The print head sprays the ink on a rotating oil-coated drum, and the drum passes the ink onto the paper. Solid ink printers are most commonly used as color printers. They're excellent at printing on transparencies and non-porous media in general. They can produce excellent results. They do, however, require lots of energy and take a long time to warm up, to start up. Dye sublimation printers employ a printing process using heat to transfer dye onto a medium like plastic, paper, or canvas. The process usually prints one color at a time using ribbon with color panels. Dye subprinters are intended primarily for high quality color application, like color lithography. They're less well suited for text output, would be very slow printing purely text and expensive. They're increasingly being used as dedicated consumer photo printers. Thermal printers work by heating regions of special heat-sensitive paper. They're widely used in cash registers, ATMs, gasoline dispensers, gas stations, and some older, cheaper fax machines. Their problem is that their output tends to fade over time. They don't last well. Daisy wheel printers operate pretty much the same way as older typewriters. A hammer strikes a wheel with pedals, the daisy wheel. Each pedal contains a letter at its tip. When the hammer hits the pedal goes forward onto pushing a ink ribbon against the page, printing the character on the pedal. Different characters are selected by rotating the wheel to bring the desired character to the top so that when the hammer goes forward, it hits the correct pedal. These printers were referred to as letter quality printers. They could produce text clear and crisp, exactly the same as produced on a typewriter. The fastest of these printers printed at about 30 characters per second. By 1980, the daisy wheel printers were the dominant technology for high quality print, commonly used in offices where they wanted to produce print that looked like it was official. Dot matrix, impact, thermal, or line printers were used where higher speed was required, poorer print quality was acceptable. Both technologies, dot matrix, thermal, and daisy wheel, were rapidly superseded for most purposes when the laser printers and inkjet printers became available. Such printers have the advantage of being able to print any character or graphics rather than being restricted to the character set on a given wheel. Pen-based plotters were a printing technology that was very common in engineering and architectural firms. Pen-based plotters draw on the paper. They don't bang against the paper. Special purpose pens are mechanically raised and lowered so that as they move, they either make a mark on the paper or not. Their movement of the pens then draws text and or images on the paper. Since our pens are drawing continuous lines, they can produce technical drawings of very high resolution, much higher than was available using dot matrix technology. Some plotters used roll paper and could make very, very long documents, limited on the width of the documents, but unlimited in the length. So they're capable of producing very, very large drawings. Text can be printed in various sizes and various styles. Technically, the term font refers to the combination of font face, font style, and font size, but it's very, very often used as just the style or font face. Font face or typeface is the style or appearance of the characters, what they look like, how they're shaped. They come in two general classifications, serif and sans serif. A serif is a small line attached to the top or end of a stroke in a letter or symbol. Typefaces with serifs are called serif typefaces. Typefaces without serifs are called sans serif. There is debate as to which is better, which is easier to read. There are studies that support both sides of the issue. One of the most common serif fonts is Times New Roman. Here we have an example of Times New Roman text. As you can see, the A has little lines at the bottom. The C has a little jag at the end. There's a little jag at the end, top and bottom of the D. X has lines on the ends of the lines, and so on. A commonly used sans serif font is named Arial. Here we have an example of some text with Arial font. As you see now, comparing the X in Times New Roman and the X in Arial. With Arial, the lines go to the top and stop, and the Times New Roman goes to the top, and there's a little line at the end, on the top and on the bottom. The term font style refers to whether it's printed using any of several properties, and each of these properties can be used in combination with any or all of the others. The proper style properties are bold, italicized, and underlined. Font size, or text size, is the overall size, usually describing the height, of a font as it's displayed on the screen or printed on the page. Font are typically measured in points. That's the vertical measure of the lettering. There are 72 points in an inch, or 1 point is 1/72 of an inch. The measure of as points was pretty much inherited from physical typography, refers to the smallest unit that they could design to be printed. Standard for computer use was defined by Adobe when developing Adobe PostScript. Points are the traditional measure of fonts for computer monitors and other types of displays that can also be measured in pixels and picas. It can also be measured as ems. That's the width of the character M in the current font. The M measurement is convenient for defining sizes of individual characters relative to characters around them. Computers can produce audio data, and audio data requires an output device like a speaker or a headphone to deliver the sound to the user. A computer speaker is a hardware device that connects to the computer to generate sound. Headphones are pairs of small listening devices that can be worn on or around the head over the user's ears. Headphones are designed to allow the single user to listen to an audio source privately. A computer speaker, on the other hand, produces sound that blasts out into the open air for anybody nearby. Circumaural and supraaural headphones use a band over the top of the head to hold the speakers in place. An alternative type is an earbud or earphone. These consist of individual units that can be plugged into the user's ear. In the context of telecommunication, the word headset is used to describe a combination headphone and microphone.